Alright, so I got some really good news. It was daylight savings time last night, but it was that in a good way where I got an extra hour, so I have an entire extra hour today to do a JNCIE-SP video. Even better news than that, I've only got 2 topics left before we're completely done going through every topic in the curriculum. Now at that point I would like to change my study quite a bit. Basically I would like to focus more on kind of memorization type stuff. One strategy I like to do when it comes to that sort of stuff is let's do like something like memorize this line. So one thing I like to do is save that somewhere. So like in the next page, or in a, well, it wouldn't be there. It would be like here, yeah, and then just try your best to, if you get it wrong, that's fine. Look at the answer, and if you get it right, then you're probably good enough. But if you get it wrong, delete it and try it again, and just keep doing that until you get it right. Do that over the course of days. Anything you consistently get right, you really don't need to practice that much. You can take it off the pile of things you need to do, and then you're just continually practicing the things you get wrong. I find that's a pretty quick and effective way to memorize things. Alright, so next topic is rewriting. Oops, and it looks like I created a new folder instead of a new file. Oh, the other thing I forgot to do is mark that I had completed queuing. I'm pretty satisfied with what I did on that. It's just one video, but not every topic requires a whole series of videos. Okay, and I will need to take a quick break. I'll be right back. Okay, I'm back. So let's do the same thing I do every time, getting comfortable using the help menu, because memorize as much as I can. It's just gonna fail me at some point. Of course, the help menu has failed me a lot now, and it's gonna fail me as well. But that's why once I'm done with these 2 topics, which hopefully I'll be done with them today, but I'll for sure be done with them by the end of this week. Probably a lot sooner than that. I'm going to be changing my study quite a bit to more like kind of route memorization and really getting the configuration under my fingers a lot better. So help apropos. So here we go. We've got a lot of good results. Alright, so let's start with default here, rewrite rules default. Okay, so applying default rewrite rules. By default, rewrite rules are not usually applied to the interfaces. The exceptions are MPLS interfaces. All MPLS enabled interfaces use the default EXP rewrite rule, even if not configured, except for MPLS interfaces. If you want to apply a rewrite rule, you can either design your own rule and apply it to an interface, or you can apply a default rewrite rule. To apply default rewrite rules, include one or more of the following statements at the edit class of service, interfaces, interface name, unit, logical unit number, rewrite rules, hierarchy level. So we can include DSCP default, that same thing for IPv6, EXP default, IEEE 802.1, and INET precedents. Default packet header rewrite mappings shows the default rewrite rule mappings. These are based on the default bit definitions of DSCP, IPv6, EXP, IEEE, and IPCOS values, as shown in default COS values, and the default forwarding classes shown in default forwarding classes. When the software detects packets whose COS values match the forwarding class and PLP values in the first two columns in default packet header rewrite mappings, the software maps the header bits of those packets to the code point aliases in the last column in default packet header rewrite mappings. The code point aliases in the last column map to the COS bits shown in default COS values. Okay, so here we've got the default packet header rewrite mappings. So that's good to know. Don't need to memorize anything, it's all right there. In the following example, the interface is assigned the default DSCP rewrite rule. One result of this configuration is that each packet exiting the interface with the expedited forwarding class and the high or low loss priority has its DSCP bits rewritten to the DSCP EF code point alias. Default COS values shows that this code point alias maps to the 101110 bits. Another result of this configuration is that all packets exiting the interface with the best effort forwarding class and the high or low loss priority have their EXP bits rewritten to the EXP BE code point aliases. Default COS values shows that this code point alias maps to the 000 bits. To evaluate all the implications of this example, see default COS values and default packet header rewrite mappings. Okay, so looks good to me. You just go under the interface, under class of service, and the word is rewrite rules. Let's take a closer look at that. Okay, so what does it say for rewrite rules? Rewrite rules applied to outgoing packets. Important to know. Good thing they include that there. Yep, and then we've got different kinds of bits to rewrite depending on whether you want to rewrite the frame, the packet, the MPLS label. And I'm not sure why there's 4 of them. I guess I was thinking there are only 3, but it looks like there is a 4th. So let's take a moment right now and really get a good sense of each of these kinds of packets. Or, sorry, not packets, each of these kinds of bit markings. Yeah, it looks like there's even yeah, so I don't know why they leave out the P there. Like, if they just had the P there, it would be a lot easier on me. But they took it out. Ah, I see, Q and Q. Okay, so we got some decent resources here for everything. Let's just try to find a quick summary or something like that. We'll just go with the first thing, and we'll just go across the tabs and read a quick overview or summary for each of these. DSCP marking is used to determine traffic classification for network data. This can be used to determine which network traffic requires higher bandwidth, has higher priority, and more likely to drop. Okay, well, you know what? Let's go like this instead. Let's do a images search. Yeah, and this is exactly what I want to see is some sort of yeah. So here's an IP packet. So but I want to see the oh, okay. So it looks like it's in the IPv4 packet. The SCP is, but it's before the IP addressing. So let's grab a IP packet. Okay, so here we have an IP packet. So, yep, and here we have the differentiated services field. So we can see it's before the addressing information. The addressing information starts here. It's at the very last thing contained. And then the next part is the segment. So a data is kind of like a bookshelf where you have different kinds of books, and you keep all your books organized in a certain way. So these are going to be the very last books at the end of the bookshelf. There's a bunch of books in the beginning, and and among the first are the differentiated services field. Okay, so let's try to figure out where the MPLS, that's an easy one. It's in the MPLS label. Okay, so let's see where IEEE P802.1 IP is. Okay, so we'll go and do a Google image search. Okay, so here we've got 802.1p. Okay, so I actually had it flipped in my mind. I thought that DSCP bits were for layer 2, but it turns out they actually are for layer 3. It's 802.1p that are layer 2, which makes a lot of sense because 802.1p bit marking is something I've done a lot at my previous job, and my previous job was like all layer 2. So yep, so if we go here, layer 2, the frame header, we should see okay, so it should be after the source address. So yeah, so this type field. Huh. Oh, you know what? That's probably because I don't have... Oh, it's in a Vlan tag. So you have to have a Vlan tag in order to have 802.1p bits. Okay, but we can do that. Let's set up a Vlan tag to take a look at those 802.1p bits. So oh, let's set Vlan tagging. Okay, and then edit set unit 10 Vlan ID 10. Okay, and now edit unit 10. Perfect. Yep. All right, we're good to go. Okay, so now let's take a look at router 2. Oh, okay. Okay, so let's clear off the firewall config. All right, and then we'll change this to be on a VLAN. Okay, so we should have a VLAN tag now on our packets, or on our frames rather. So I'm probably going to need to restart the capture. Huh. Okay, so it looks like there was some kind of issue with my config. Maybe I configured the wrong side. Okay, that looks good to me. And now we've just got some regular pings. That'll be fine. We can see we do have a 802.1 header now, and so now we've got priority. So here's going to be the bits, the 802.1p bits. They're in the VLAN header. So, yep, so the VLAN header consists of the priority, the CFI, and the VLAN ID. So, priority, CFI here, which looks like it's listed as DFI, and then VLAN ID. One really cool thing about, and it's also got the type listed as well. I don't see where the type is. Do they? Where's the type? Alright, well that's strange. But TCI, is that it? But one thing that's kind of cool about Wireshark is you can go right click and then you can go Wikipedia protocol page. So the Wireshark wiki is maintained by the community. The page you're about to load might be wonderful, incomplete, wrong, or inconsistent. So one thing I urge everyone to do who's a frequent watcher of the channel and who uses Wireshark, build this. Because, you know, imagine using Wireshark saying, oh, what the hell is a DEI? Right-clicking and going Wireshark protocol page, and it's just the best documentation you've seen on the web. It's better than anything else you can find. Imagine that. I mean, that would make Wireshark such a more powerful and useful tool to have that. So, and not only that, you get your name, you get your recognition. I actually, so to do it, so to do this, you just need to send an email. You need to create an account, and then you need to get write permissions. So I have an account. And then I emailed for my write permissions. It gives you instructions on how to do that, I believe, after you create an account. Oops, and it looks like the wiki is in a new location now. But you can see any protocol you want. It's just going to be listed right here. Yeah. So we've got 46 results. You can use the search, hopefully, if there's one. Well, you can probably use this one here. So let's look up LLDP. Okay, so it looks like we've got some. Yep, so here's the documentation that they have for LLDP. So look at this, it's all there, ready to go. Add an example traffic here. So anyone watching this channel, if you want to, you know, even if you're going for your JNCIE-SP, or even if you're not even interested in a certification at all and you want to just focus on this, learn how to use Git, learn how to clone this repository, learn how to push things up, and you're going to have your name all over Wireshark, and that'll be just really, really good kind of marketing for yourself, and really, really good benefit to the Wireshark community. And you know, as I said, you don't need to be going for your IE. You don't even need to be particularly skilled. Basically, you just, here it says, so, oh, okay, it looks like they've already got one, yeah. Yeah. So they've already got one there, but I'm sure there's plenty. I mean, look at all the protocols here. There's some where they don't have captures for, so if you can find a way to capture that and just upload a picture. There's just a lot of low-hanging fruit here, and really good, a lot of really good work to be done. Okay, so yeah, one thing I would like to do for Wireshark is make just fix the Wikipedia protocol page to, yeah, because right now it does it by the link like that, but we can change the link. So this is ip.version. Let's see if we've got ip.version. We don't, unfortunately. Well, that sucks. It's not quite as seamless as it used to be, this new wiki. That's too bad. Alright, but let's not get too distracted here. Let's go ahead and move on to the next bit marking. So we found that DSCP, basically kind of your generic layer 3 bit marking. It's going to be at the beginning of the IPv4 packet, beginning of the IPv6 packet as well. The IEEE p-bit, you can only have that if you're tagging your traffic with Vlan tags. And once you do that, it's just right at the beginning of the Vlan tag. IEEE 802.18d is something known as Q&Q. It's for service provider bridging. If you want your customer to be able to mark their VLAN headers with 802.1p bit marking, you can't touch their IP, their VLAN tags. If you touch them, you're gonna overwrite and lose those markings. So what service providers do is they double tag the traffic. They just put another VLAN over it that has their own bit markings, doesn't touch the customer. It's just all seen as data. Pretty much, and that preserves the bit markings put on there by the customer. Now the two ISPs do that right every time, hopefully. Okay, so this is the one I really am not sure what this is. So an IP precedence classifier, let's see where that is in the actual frame here. Huh. Yeah, I don't see where, I mean, obviously I see this graphic here, but I don't know. Oh, okay, yeah, so this is a good. Oh, I see. So it is in the TOS byte. So this, is this a frame or is it a packet? This is one thing I kind of don't like about a lot of documentation. It doesn't tell you if you're looking at a frame or a packet. I mean, I guess you can figure it out because like packets and frames have different fields. So yeah, let's just try to determine whether this is a frame or a packet. Header, So, okay, so here's a frame header. Okay, so a frame header has a lot fewer fields. Here's a packet header. So, yep, so we got the version, header length. We've got now this is what they're talking about, the differentiated services field, DSCP. It looks like there's a TOS byte as well. Okay. And the TOS is definitely definitely part of a packet header, not a frame header. Okay. Yep, and then we've got the length, identification, flags, fragment offset, time to live, protocol, header checksum, yep, source and destination. Okay, so we're good to go. Oh. Okay, so yeah, I'm happy with having that figured out better. Alright, so let's see if there's like some sort of lab or something to do on rewriting. I mean, not every video has to be 10 hours for every subject, so. Here we go, configuring and applying rewrite rules on a security device. Okay, so I might have already... Nope, I don't think I did this yet. Okay, and here they're applying it to an interface, to an IRB. Let's just apply it to a... Oh, I should probably read this as well. Okay, so this is what I'm going to do. I'm going to read this and then do the example. Hopefully I can do that in a half an hour, and that will be the end of the video. So this is understanding CoS rewrite rules. As packets enter or exit a network, edge switches might be required to alter the class of service CoS settings of the packets. This topic describes how to use rewrite rules to alter the CoS settings. This topic covers how rewrite rules work. Rewrite rules set the value of the CoS bits within the packet's header. Each rewrite rule reads the current forwarding class and loss priority associated with the packet, locates the chosen CoS value from a table, and writes the CoS value into the packet header. For rewrites to occur, rewrite rules must be explicitly assigned to an interface. On EX series switches, you can define rewrite rules for IPv4 and IPv6 traffic to network interfaces, aggregated Ethernet interfaces, also known as link aggregation groups, legs, or port channels in Cisco speak. Routed VLAN interfaces, RVIs, layer 3 interfaces, and layer 3 VLAN tagged sub-interfaces. Multiple rewrite rules on different types can be assigned to a single interface. On EX 4300 switches, you cannot configure... okay, so we don't care about those. This will just be on MXs. So in effect, the rewrite rule performs the reverse function of the behavior aggregate classifier, which is used when the packet enters the switch. As the packet leaves the switch, the final CoS action is generally the application of a rewrite rule. You configure rewrite rules to alter CoS values in outgoing packets on the outbound interfaces of an edge switch to meet the policies of a targeted peer. This allows the downstream switch in a neighboring network to classify each packet into the appropriate service group. Note, when an IP precedence rewrite rule is active, bits 3, 4, and 5 of the type of service TOS byte are always reset to 0 when code points are rewritten. Default rewrite rule. To define a rewrite rule on an interface, you can either create your own rewrite rule and enable it on the interface, or enable a default rewrite rule. See defining CoS rewrite rules, CLI procedure. Table 1 shows the default rewrite rule mappings. These are based on the default bit definitions of differentiated services code point DSCP, which is in the IP packet header. IEEE 802.1p, which is in the frame header, but only if you have VLANs enabled, because it is in the Vlan tag, which is a part of frame header only if you have VLANs enabled. And IP precedence values, which are basically the same as differentiated services code point, from what I understand. They're just a different field of that. And the default forwarding classes. You can configure multiple CoS rewrite rules for DSCP, IP precedence, and IEEE 802.1p. Note, by default, rewrite rules are not assigned to an interface. You must explicitly assign a user-defined or system-defined rewrite rule to an interface for the rewrites to occur. When the CoS values of a packet match the forwarding class and packet loss priority values, the switch rewrites markings on the packet based on the rewrite table. Alright, looks good to me. Now there is a... oh. Okay, so there is a CLI procedure. This is for EX series switches though, so let's see what this one is for. Okay, so this is just for any device, so we'll do this one. You can configure rewrite rules to replace CoS values on packets received from the customer or host with the values expected by other devices. You do not have to configure rewrite rules if the received packets already contain valid CoS values. Rewrite rules apply the forwarding class information and packet loss priority used internally by the device to establish the CoS value on outbound packets. After you configure rewrite rules, you must apply them to the correct interfaces. In this example, you configure the rewrite rule for diff-serve CoS as rewrite DSCPs. You specify the best effort forwarding class as BE class, expedited forwarding class as EF class, and an assured forwarding class as AF class, and a network control class as NC class. Finally, you apply the rewrite rule to an IRB interface. Note, you can apply one rewrite rule to each logical interface. Okay, so let's do the step-by-step instead of just doing it all at once like that. And we'll configure it on rudder 1. Let's configure it on rudder 3 because it's got a little bit less configuration on it already. Yeah. Okay, we'll do it in accordance to the step-by-step. This is going to require a lot of scrolling back and forth. Okay, so first thing, edit class of service. And we're going to be configuring rewrite rules for diff-serve CoS. Okay, so configure best effort forwarding class rewrite rules. Okay, and this is very similar to what we did in the last video. Alright, so the next step is going to be to configure expedited forwarding class rewrite rules. So we'll be in the same config hierarchy. Okay, so on to the next forwarding class. It's going to be the assured forwarding class, AF-class. Okay, so the next step is to configure network control class rewrite rules. Okay, and then to apply rewrite rules to an IRB interface. So we're not going to apply it to the IRB interface, let's just apply it to interface 0. So we'll need to go to a different configuration hierarchy. Okay, looks good to me. So now we can do a commit, and hopefully it will commit. Oops. So it looks like I've got a class that is not defined. Okay, so I actually have to build the actual forwarding class. Yeah, and we can see they just left that out. Oh, no, they didn't. So yeah, these forwarding classes are all just called in, but not defined. We do have some forwarding classes that are automatically defined. These are the default forwarding classes. Yeah, so the ones with without a description here, I believe, are default. Okay, so we've got some more time, so let's try using the default class names. Alright, so instead of AF-class, so AF stands for assured forwarding, so we'll just use assured forwarding since that's the default. Perfect. Okay, and then BE, best efforts. Alright, and then EF, expedited forwarding. Alright, and then NC class, network control. Alright. Okay, so I did this on my second screen here, so let me bring it up to the recording. Oops, and it looks like this whole time I was capturing the wrong screen. I'm not sure how that happened. That's really strange. I've never experienced that before. Okay, it's just not capturing a screen is what's happening. So yeah, I've never seen that happen before, so apologize for that. It looks like it doesn't even see my second screen. So I've just got a bit of a technology failure here. Yeah, well, video's almost over anyway, so this is kind of a dud video. Apologize for that. So I guess it doesn't really matter which screen my stuff is at now. Okay, so the commit went through perfectly successfully, so yeah, I think that's going to be it for rewriting, and in the next video I'll make sure to do a check of all my stuff before I run. I just kind of started taking for granted things working good because things were working good, but of course with tech we all know anything can happen at any time, so the most important thing is just check and verify. Alright, so thanks for watching, and I'll see you in the next one.